coffee stains and chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode.
Hey everyone, so today I have somebody joining in from Taiwan who solved over 1,000 leak code questions and has some incoming interviews at Google and Amazon. So yeah, we're here to help them prepare. How are you feeling about these interviews?
The way the recruiter described it is going to be really tough. And since I mostly solve medium questions, I feel like if they give it hard, I'll just panic and not know how to proceed.
Yeah. So what have you already done for these two interviews? Have you already done like a tech screen and then now you're doing the on-sites for both of them?
I think now it's just all virtual on-site.
Wow.
Yeah,
So
I think Google has like three coding interviews, but the first one, if I don't do well on the first one, there won't be anything, like there won't be the rest. But if I do well enough on the first one, then I get the other three interviews, which is total of 4 rounds.
yeah.
So the first round is coding, and then 2 coding, and then 1 behavior, assuming everything goes well. That's for Google. But it's like an L4, so I think they have like higher expectations.
What about for Amazon?
For Amazon, would be new grad, so they didn't really explain the difficulty, but I think it's not as difficult as Google's for sure.
Okay. Okay, if we want to prepare you for Google and Amazon, I'm gonna have to find you some good questions. Give me a sec. Let me find you some good questions. All right, so this first question. So in this first question, what the goal is, we're gonna be given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. We need to add the two numbers and return the sum as a linked list as well.
List. Okay. And any leading zero except the zero itself. Okay. So I guess
So this is the first. This is one example.
example. Okay. So given linked list 1, linked list 2, 2, 4, 3, 5, 6, 4, because it's reversed. It's 3, 4, 2, and it's 4, 6, 5. Okay. So once you get added and then returned. Okay. So we don't have to like reverse the linked list. Okay, because the output is also reversed, so we don't have to reverse the output again. Okay. Similar to no leading zeros. So by leading zeros, it means like nothing like this, right?
Yeah.
Like 2, 4, 3,
Yep,
0,
yep.
because it will be leading zero to the right side. Okay. In that case, I think I can loop through both linked lists at the same time and have like a carry variable. If carry is 0 or 1, and while there's still a number left for L1, L2, or carry, I just keep going to the next, and then add the two numbers together plus the carry. If it's greater than 9, then I have to put another carry will be equal to 1, and then I can move on to the next one, and then append a new node, and then return the whole new linked list. I think that can work.
Okay. Makes sense. Go ahead and implement.
Okay. So let's see. Probably want a dummy node. Do we know what the node class looks like, or
You can create it yourself. Like figure out, or what was gonna look like. Yeah, you tell me. Like
Okay.
you could define that.
Probably. Okay. Then probably a this node. And let's see. We will need a value and the next. So value and next node. So self dot value equals value and next equals the next node. That should be okay, I think. Yeah, just the value and the next node. And yeah, so if I do a dummy node, that should be okay. Oh, but do I need to create like a
Yeah. Create me a function that takes in two
yeah.
lists and will return the
create
output
a
list.
function, right? So call this add list. So we have L1 and L2, and then return a list node. So, okay, so I need a dummy node that starts, and then a carry, and then the current node. Then dummy dot next equals current. Then, well, L1 and L2 and or carry. While they all have values, then I want like a new value is L1 dot value plus O2 dot value plus carry. And then if the new value, well, actually, so new value, and then the current value needs to be new value mod 10. So it needs to get less than 10 value for the current, and then let's see, carry will become new value divided by 10. And then I need to check if L1 exists. So let's see, L1 equals L1 dot next if L1's still dot next if L1 still exists. But actually, what if can L1 be just no values?
Are you saying like what if they're different sizes?
I think they can be different sizes.
Yeah,
That
they
should
can
be
be.
okay. It's like if L1 equals this,
No, like each one of them has at least one element.
has at least one. Okay, that's at least one. Okay. So first one. So
Two, yeah,
this
two
next.
non-empty linked lists.
Okay. Next, if L1 Okay, I should probably be use like v1 and v2 then. v1 equals L1 dot value if L1 exists, else it's 0, and same with v2 if L2 else is 0, and have v1 plus v2 plus carry, and then become when L1 gets next if L1 still exists, else it's none, and same with L2. Okay, so current value is safe, but now I need to move current to current next. But I think I should declare it, or no, I think okay, maybe I don't even need it. I'm overthinking some of the order for the list nodes. So it would be current dot next equals a list node of I don't know why it's saying that. Okay, yeah, a new list node of the value, and then I can go to the next, and then once L1, L2, and carry are all 0, they're all none, and carry are all 0, then this will break out. Once it break out, I can return dummy.next. So I think that's the overall logic. But I'm gonna do a dry run just in case and check. So let's do a simple example.
Yeah, do like 9 plus 12.
9 plus 12.
Or
Okay.
something.
Let me, 9, and then L2 equals 9 plus 12, like that. Okay. So
It's gonna be more like in reverse order though, so 9.
Oh, right.
So like 2.
Right. Yeah.
Yeah, walk me through.
Okay, yeah. So L1 is 9, L2 is 2. So they all still exist, and carry is 0. And then L1 gets the value 9 because it still exists. L2
Oh, wait,
gets the
walk
value
me through
2.
here. Line 30. You create the dummy.
Okay, yeah. Create a
Set the
dummy
current
node.
dummy. Okay.
And then I keep track of the dummy node in current. And then I initialize carry to 0. And then while L1 node and L2 node or carry exist and carry is greater than 0, L1 and L2 both exist, so goes into the loop. For value 1, L1 dot value exists, so it's 9, and for V2, L2 value exists, L2 exists, so it's 2. So new value is 9 plus 2 plus 0 should be 11. So current.next will be a new node with 11 mod 10, so it's going to have a value of 1. And then carry should be 11 divided by 10, should be 1. So carry will become 1. And then I could check the next value for the node. So L1.next if L1 exists, which L1 exists, so it's going to become L1.next, in which case it's going to be none. And then L2 next will be to the one node, and current will become current next, this new node. So it's going to loop back here. L1 is none, but L2 still exists, and carry is at 1. So V1 is going to be 0, and V2 is going to have 1 because it still exists. The node at 1 exists, and so it's going to be v2 is going to be equal to 1. So it's going to be 0 plus 1, and carry was 1, so it's going to be 2. Right, 2, and then kernel next, create new value 2 mod 10 will be just 2. And then carry is going to have, carry is going to be 0 now, because 2 divided by 10. And then L1 is going to next, if L1 exists, L1 or doesn't exist, is going to be none, and L2 is going to be next, which is none, because we're at the end. And current is going to be same as this new node, and after that, it's going to come back and check L1, L2, or carry, and L1 is going to be none, L2 is none, and carry is going to be 0, so it's just going to break out of the loop and return dummy dumb next. Dummy dumb next.
Yeah, I think it's good. Let's just move on to the next question. Good job. Okay, this is the next question. What we're gonna do is, and I want to make sure you hit the right O-Van time complexity, but we're gonna be given an unsorted array of numbers. We need to return the length of the longest consecutive element sequence, and it must run in O-Van time. So, for example, here the longest consecutive element sequence is 1, 2, 3, 4.
Okay.
Therefore, its length is
1,
4.
2, 3, 4, and therefore its length is 4. So, okay, so we are only returning the length. Okay, length of the longest consecutive elements sequence, and it's not sorted or anything. So 104, 200, 1, 2, 3, and 1, 2, 3, 4 will be 4 consecutive length sequence, and that's why we return 4 here. And in this case, I guess it's 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0 to 8 is 9 length, and here is 0, 1, 2, so it'll be length of 3. Okay. And it looks like there can be duplicates for nums as well. In that case, can nums will always have at least one value, right? It's not going to be an empty list. Is that a possibility, or?
Wait, sorry, can you repeat that?
Nums will always have at least one value element, right? It's not going to have an empty list.
It could be an empty list too.
Oh, nums could be an empty list. Okay, then that's probably an edge case. I'll have to check. Nums is valid. I'll have to check that. Then return the length. So in this case, we'll probably return 0 because there are no values. Okay, that makes sense. All right, and since there can be duplicates, we probably want to use a set to put all the numbers into a set, and then by checking if and looping through each number in the set, I can check if the left side of the left number to this current number, if it's in the set. If it is in the set, then I'm not at the beginning of like a number line. I'm not at the very left side. So in this case, using example 1, if I'm at 4, I'll check 3, and 3 still exists here, which means I'm not at the very left. So I can, and then go on. If I check 200, 199 is not in here. That means I'm at the start, and then I can start counting like 200, 201, 202, and then go on. But in this case, it's just going to be 200 and have a length of 1. And then if I get to 1, I check 0. 0 is not in the set, so I'm at the beginning, which means I can start running 1, 2, 3, 4, and then have return a length of 4 because 5 is not in the set. I think that can be a solution.
Okay, that makes sense.
Okay. So define the function first. We'll call this longest consecutive length, and then the nums return an integer. Okay, so I need to create a set first. So a set of all the numbers in nums, and then for each number in set, if num minus 1 is not in the set, that means I'm at the beginning of the number line, and then I can start counting. So I equals 0, while num plus I is in the set, then I plus equals 1. And then we have return, which is by default a 0. And then result by default 0, plus equals 1. And then result is the maximum of result, or let's see, if I equals 1, if I is 1 and it's in the set, then keep adding. If it's not in the set, then it breaks. So that should be okay. So for each, it's not in, keeps increasing and checking and returning, and then otherwise return the result. I think that's okay, but I need to do a dry run just to check.
Yeah.
So
go ahead.
Let's see. Can do the example 1. Dry run. So set is gonna have all the unique, just the same numbers, and then it's gonna, for num in S, so it's just gonna start looping through the set. If num minus 1, which is 99, it's not in the set, which is not, and then it starts checking I equals 0, which is in, and then I plus. I guess technically I can start with I equals 1, but I can save a loop. But yeah, so what is it? 100 plus 100 is in the set, and then 101 is in the set, is not. So I equals 1, and then max will be 0 or 1, so it's going to become 1 because it's just 100. And then for 4, num equals, for 4, 3 is in the set, so it's going to skip that. And 200 is going to be 199 in the set, and then I equals 1, so 199 plus, 200 plus 1's 201 is in the set, it's not in the set, so it's just going to have I equals 1, and result is already 1, so it's still going to remain 1 for result. And then it's going to get to 1. 1 is going to have check 0. 0 is not in the set, so it's going to start counting 1 plus 1, 2 is in the set, plus 1, 3 is in the set, plus 1 and 4. 4 is in the set, and I is going to be 5. 5. I think there might be an error here, actually. Yeah, I minus 1, because when there's four numbers, I to 1 to 4, when I equals 1, and I is going to be added by 1, and that's the one that doesn't work. So if it's one number, 1, and then it's in there, if it's not in, wait, hold on, I might have confused myself here. 1, 2, 3, 4. Num is 1, and so plus 1, 2, 3, plus 3. So 1 plus 3 is still in I equals 3, and then I becomes 4. Mm-hmm. And 4 is when it doesn't work. So actually, I know I confused myself and tried to think. I just shouldn't have to minus 1 here. Okay. And then 1, and then 3, 2 is 2 is in the set, it's not going to work. And for 2, 1 is in the set, that's not going to work. And that should return length of 4 for result. I think that's okay. That should be okay.
Nice. Okay, run it, like write a couple test cases, ensure, or run it across run it on these examples and just ensure.
Yeah. Let's see. We can use this one and this one, and I can probably still run the original as well. I think it just run and see, or does it not run if I click run?
Should run. The first one.
9, 3. No, first one is actually this one.
Yeah.
The order is a little wrong. So 4. Okay, I think that's okay.
Nice. No, you're solving these fast.
Now these are like semi done before, but like as you can see, like there's still mistakes with my. I confuse myself when I is 1 or should be subtracted by 1. The little things like that.
Okay.
That throw me off. And
okay, final boss.
Final boss. Okay. Okay. Let's see. F n dice, and each dice has k faces numbered from 1 to k. Okay. K face dice. Given 3 integers nk and target, return the number of possible ways out of the kn total ways to roll the dice. So the sum of the face-up numbers equals target. Since the answer may be too large, returning modulo. Okay. Look at an example. You throw 1 die with 6 faces, and there's only one way to get a sum of 3. So return 1. You throw 2 dice, each with 6 faces. There are 6 ways to get a sum. 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 6. Okay, so the order does matter. 5 plus 2, 6 plus 1, and that's 6 ways. Okay. And then with 30 dice, and then 30 faces, and we want 500, the answer must be returned, and then that's a huge number. Okay. I think I understand the problem. Now I need to think of a good solution to do this with. Not sure if I've ever done something similar to this problem before. Probably not. Return the number of possible ways to do this. Targets. How many ways we can do this and add up to this of k to the n total ways.
You get the question?
Yeah, I understand the question, but I'm trying to think of a good solution, good method to solve. If I try every possible combination, that's not going to happen. So I'm trying to think, but so if because k is six-sided, which means I get a sum of, for each die get a sum of either 1 to k. So that's the sum I can go with. I have a question. Let's see. If there are 2 dice and let's see, target is 6. then it should be 2 plus 4, 3 plus 3, 4 plus 2. Will I get another 3 plus 3 here? So there should be 4 ways. Or wait, not just 4. Obviously 1 plus 5 and 5 plus 1. It will be return 6, right?
Where 2 dice target 6.
Yeah, 2 dice, target is 6, and k equals 6, suppose.
Yeah. So we have 1
It
5.
should return 6 ways, because 3 plus 3 and 3 plus 3 are two different, the order is different, so it gets counted individually, right?
I think so.
Okay.
Wait, 3 plus 3. No, these are the same. These are the same.
These are the same?
3 and 3.
Oh.
Yeah, because one of them is 3 and the other is 3. So like,
Okay.
well, because one roll, these are the same, not no. Like one of them is 3 and the
Yeah,
other is
they
3.
are the same, but the first one is the 3, second one's the 3, and then first one's the 3, second one's the, so
Well, the first one here is a 3 also, right?
yeah. Okay. So it will just
I
be
think, yeah. Let's see.
5 then. Okay. So, okay. Should I get a some, like, I understand the question. I'm trying to think of a solution and I'm technically drawing a blank here. So, not sure how exactly to proceed. Should I get a sum of 1 to k? So if I get k, target gets subtracted. No, that's not gonna. There are 3 ways to do. If I get one for the first die, second die is 1, 3 dice 1. Depending on the die, given a sum of 1 to k. How can I reduce the number of total possibilities and just add to the answer?
So what would be the brute force?
Brute force will probably be checking every possible way. So like I roll like 1 to k for the first die, and then check 1 to k for the second die, 1 to k for the third die, and then just see until I roll all of them. If the target is like if the total sum is equal to the target, then I can return +1. That's one way. Like there would be then one way to roll the dice.
Okay.
But that'll
So
be
like
like
roll the first. So you'll just.
after.
So we could explain it. So you roll the first dice, and then
Yeah,
you see
roll the
that
first
all the different
die.
combinations, the second dice, can be added with the first dice.
Yeah. I mean like checking every possible combination until like and see if the total sum equals the target, and then that will be +1.
How would you generate all the possible combinations?
Um, I'll probably have to do like for loop from 1 to k, add to the sum, add to the total, and then move on to the next die, 1 to k, and then do like a recursion, add to the total, and then third die, 1 to k, add to the total. But that's like super exhaustive and very brute force.
Mm-hmm. What
I think
would
that
your algorithm be at that point?
that will probably be k to number of dice. So k to the n. Yeah, that would be k to the n total number of ways. And because I'm checking every single method.
Yeah.
Yeah. Maybe I can reduce the target every time I throw a die, and if I, early pruning, if it's over the target, I can just return and not proceed because I'll be over the target. But even then, that's still close to k to the n ways. If I roll a die, and then how many ways left are there to roll the rest of the die?
I think the brute force makes sense, but it's definitely gonna time out.
Yeah.
So what are ways that you could optimize that sort of brute force approach? Because it's like a recursive
Um,
brute force approach. What are like the usual ways that you could optimize recursive brute force approaches?
recursive brute force probably. I think it might be dynamic programming. Something like dynamic programming to say, hey, with the number of no, with that, yeah, I think yeah, because like, hey, with the number of dice left, and then this is how many faces it has. With the number of dice left, uh, how many ways there are to roll the rest of the dice. So I think dynamic programming can work here. Dynamic programming is like one of my many, I guess, many weaknesses.
Okay,
It's hard to
go ahead
understand
and
them.
implement out the brute force solution that you mentioned.
Brute force. Okay. Let's see. Three possible ways. Dice ways. NK and target. Then equals 0. Probably like a backtrack I and the total. Then local result. If I equals then result plus if I equals and total equals target. And then I can call like a backtrack of 0 with 0 total and return the result. Oh God. Okay. So I can sense target, and then I for shade in range of 1 to k plus 1 total plus equals j, and then I'll backtrack the next dice, and then give the total, and then total minus equals j, and then I can call the next one over and over and over. I
Which
think
J here? J. Oh, okay, total.
J. I guess J would be the face that it rolls on. So if it's 1, then you get add 1 to the total, and then I guess this makes more sense. Adds to the total, and then just keep checking until if the total is equal to the target, then no, that's one successful way I get at the end.
Okay, let's run it on a few examples.
Examples. All right, let's try n equals 2, k equals 2, 6, target equals 7. Then backtrack starting from 0, 0, and then I equals n. I said 0, so it's just gonna continue here. So for j, it'll be 1 to k plus 1. So start with 1. Total becomes 1, and then I plus 1. It's gonna call backtrack, so it's gonna call the next I, and then it's 2 for I, and then 2, and then it's gonna call
It makes sense. Let's
total
just run
1
it
to.
on like K equals 6 or something.
Okay.
Run it on this guy.
think something would be wrong. Like I'm not checking for the 3-3 earlier example. That might be a problem for excessive. Oh wow, excessive output. Did I check for? Oh yeah, if total is greater than target, I need to get out. So that should make it 6. But I think it's gonna, it might fail for this one because 3 and 3, they count as 2 separate. So if I run 266, it gives 5. Oh wait, no, yeah, this one takes care of that case. Okay. But yeah, this is the backtracking worst case scenario brute force. And then I'll have to, not sure if I can think of a dynamic programming way to speed this up.
Yeah, let's see.
Like, what would be the usual way you would approach this?
Well, you'd want to start cache, like when does it start repeating sub problems? Like when will it? What are the different sub problems? Like, I'll give you a hint. What will it ever call backtracking with the same exact parameters?
Backtracking with exact same parameters. If total is the same, but if total is the same, and then I guess there are the same number of dice left to check, then it's gonna do the repeated work, right?
Yeah, like anything. Basically, just try to figure out where work is being repeated, and if you can cache that. Cache that is just build a hash map with maybe the key is the cache key, and then store that value, and then probably somewhere here. Check cache. Because what's taking a lot of time? This backtrack right here.
Right.
So if somehow you don't have to check that.
Okay.
Like you don't have to go all the way down.
It would be like dp of I guess something like I or j, and then or I, and then I guess total, the new total, and then that would be the key, I guess. Right.
Mm-hmm.
And then I have to, like, the first time I do it, then I save that value, and then I can just, hey, if the, if that I total is in DP, then just, I guess, return that. That'll be faster.
Yeah.
Okay. So that's the approach that I have a hard time like converting a problem that's like brute forced to a DP solution. Okay.
Yeah. Since we're pretty much out of time, I'll share what my solution would look like.
Okay.
It's just kind of similar.
Target. So it would then backtrack. Oh, okay. So
all you need to do is just cache.
Run backtrack, but this is where you find it. If it's already there, then when it runs backtrack, it gets that, and then you save it because you finish running here. Okay.
Yeah, I'll be like if we have 5 dice left and we have the target.
Mm-hmm.
This is the result. So if we ever see that again, if we ever get the input that we have 5 dice left and the target.
5 dice left. And the
like,
target. Okay.
Yeah, we're basically just caching some of these backtracking calls.
Would target be this? Oh no, you're changing target here. Okay. Yeah, that makes sense. But, okay, I need to think about that kind of approach in an actual problem. Okay.
Yeah. Overall, pretty
This-
good. Like you
this is
solved
a-
3 questions, or yeah,
Is this a medium or a hard problem for
Medium,
the
medium.
dynamic programming?
it's a
It's
medium.
right, yeah.
It's very. It's like boilerplate dynamic programming.
Uh-huh.
Like you could see, like you almost were there. If you just add like 3 extra lines, you're gonna get there.
Okay.
But with a lot of DP questions, it's that simple where you build the backtracking and then you just figure out how you're gonna cache it. You can see
Okay.
mine is very close to yours, but I just cache it.
Right.
So once you get it working, just practice a bunch of DP questions because Google likes to ask DP questions.
Okay. I think Google likes to ask DP and graph, these two type of questions a lot.
Yeah.
Uh,
But yeah.
okay.
Cool. Thanks for hopping in. My eyes are burning, so I'm gonna go eat.
Oh yeah, you've been like on for like so many hours. Thank you so much, James.
Yeah.
Like, take a break.
Good job. Good job. All right. Catch
Yeah,
you.
thank you so much.
See ya.
All right.
Peace.
Thank you.